Hey, so we all use the internet every single day, right? Sending emails, watching videos, all of it. We throw around words like the cloud and cyberspace, but what's actually going on under the hood? Well, today we're going to pull back that curtain. We're going to demystify the very physical reality of the internet by following one single piece of data on its absolutely incredible journey. And trust me, you might be surprised by what we find.
So just picture it. You've typed up that super important message, you click send, and poof, it's just gone. But where did it go? It didn't just evaporate into thin air. Nope. It just embarked on a crazy high-speed trip across a very real, very physical landscape. And we're going to follow it every step of the way. All right, so the very first leg of our email's journey is just getting out of your computer. This is that critical moment where the digital world has to make contact with the physical world to get your message moving. Think about it. Every single device on a network, your laptop, your phone, your smart TV, has this little gatekeeper inside called a network interface controller, or a NIC for short. You can think of it as the on-ramp to the data superhighway. Its job is to take all the digital ones and zeros that make up your email and translate them into electrical pulses or flashes of light that can actually travel somewhere. Okay, so once those signals are ready to go, they basically have two ways to start their journey. They can go through a physical cable, that's the wired path, or they can fly through the air as radio waves, which is, the wireless path. Both get the job done, but what happens next is a little different for each one. Now, if your data goes the wired route, it's traveling on one of these physical highways, and it's really useful to think of them like different kinds of roads. That twisted pair cable, that's like the local streets in your neighborhood. Totally fine for your house or the office. Coaxial cable is a bigger, faster road, kind of like what your cable company uses to bring you internet. And then you have fiber optic. This is the absolute best of the best. This is the global superhighway, the backbone of the entire internet, zapping data across the globe as pulses of light at, well, pretty much the speed of light. It's amazing. Okay, so our email is officially out of the computer and on a physical path. But hold on, it's not on the public internet just yet. First, it's got to navigate its local neighborhood. Your home network, your office, maybe the Wi-Fi at your favorite coffee shop. So way back in the early days of networking, you'd find this little device called a hub. And honestly, the town crier analogy is perfect. A hub is super simple, but that's also its biggest problem. When it gets your email, it has no idea where it's supposed to go. So it just shouts it out to every single computer it's connected to. As you can imagine, this is just noisy, super inefficient, and it creates a ton of digital traffic jams. Luckily, we've got something way, way smarter now, the switch. A switch is like a smart mail carrier. See, unlike the hub, a switch actually pays attention. It learns the specific address of every device plugged into it. So when your email shows up, the switch knows exactly which port to send it to and creates a direct, private line for that delivery. No more shouting, no more wasted traffic, just clean, efficient communication. So what's the big deal here? Well, it all comes down to one word: intelligence. A hub is basically a dumb repeater, just creating this digital free-for-all where messages can literally crash into each other. A switch, on the other hand, is an intelligent director, creating a smooth, efficient, and super fast local network. This one innovation is a huge reason our modern networks can handle so much data. All right, our email has successfully navigated the local neighborhood. Now it's time for the main event, getting out onto that vast, global highway of the internet. And to do that, we're going to need some traffic cops. This right here is probably the most important device in our email's entire journey, the router. If a switch manages traffic in one little neighborhood, a router is like the director for all the highway interchanges connecting every neighborhood in the world. Its whole job is to connect all these different networks and make incredibly smart decisions about where to send data next. So how does it do it? Well, it's this lightning-fast four-step process that happens millions of times a second. First, it gets the data packet. Second, it reads the final destination. That's the IP address, which is basically a unique street address for any device on the internet. Third, it checks its internal map, called a routing table, for all the latest traffic info. And finally, boom, it forwards that packet along what it calculates to be the fastest, most efficient path at that precise moment. And this is a really key thing to understand. The internet isn't one single road from point A to point B. It's a massive web of countless possible routes. Your email might actually get broken up into dozens of tiny packets, and each one of those packets could take a slightly different path across the country or even across the world. Routers are constantly talking to each other, rerouting traffic around digital traffic jams or outages just to make sure your data gets where it's going as fast as humanly possible.
So there you have it. From a simple click to a global journey across this incredibly complex physical system, all in the blink of an eye. Let's just quickly recap the physical path our little email just took.
So let's put it all together. It started at the NIC, which translated your data. It traveled through a cable or through the air. It got directed around your local network by a smart switch. Then it hit the internet through a router. From there, it hopped between countless other routers all over the world, like a high-tech relay race, until it finally arrived at its destination.
And this right here is the most important thing to take away from all of this. The cloud isn't in the sky. It's on the ground. It is a massive, tangible, physical network of billions of devices and hundreds of thousands of miles of fiber optic cables running under our streets and across the floors of our oceans, connecting entire continents.
You know, more than 100 years ago, Henry David Thoreau wrote, "Men have become the tools of their tools." And that feels more true today than ever, doesn't it? We rely so heavily on the internet that we often just forget the immense physical infrastructure that makes the whole thing possible. We've mastered using the tool, but how the tool actually works, that often remains a complete mystery. So the next time you hit send, just for a second, remember that incredible physical journey your data is about to take. Now that you've seen the cables, the controllers, the switches, and the routers, maybe that abstract cloud feels a little more connected to the earth right beneath your feet.